Howdy everyone, this is Boone, and today I'll be doing problem number 2 on the radar transfer poly sheet homework. A couple of notes I have to add into this video. This video is not intended for actual radar transfer. This is simply a simulation use for educational purposes. And if any I-Nav teachers are watching, this video is not a replacement for your class. This is simply additional help that I like to give to my classmates. Now, I'd like to draw your attention to the problem right here and a bunch of acronyms on the side. If you do not know what these mean, I would highly recommend taking a look at the homework sheet. I will be pointing them out what each of them mean in the video as we progress. The problem follows doing all these in sequential order, so it is a nice aid to have when you're doing the problem. You are given some information in the problem, like your own ship's course, ship speed, time, bearing, and range of the other vessel. So with those two pieces of information, we can put together where the other vessel is relative to us and predict where it will be heading to. A couple more notes I'd like to add in before we get into the actual problem is plotting gear. I am using a Wings of Plath ultralight divider. Highly recommend if you need to pick one up. You need a divider for this. I really can't see a way of doing this without a divider. But if you do not have a triangle, I have a triangle, but if you don't, I would recommend using some household items like a ruler or something that you could keep a consistent bearing on. Find consistent methods with whatever gear you're using and make it precise as possible, because if you don't, these problems will come and bite you. Alright, now that I got all that information out of the way, let's get right into it. The first thing we are solving for is DRM. But we need to do a couple things before we get that. DRM stands for direction of relative motion. And we need to do three things, which is find R00, R06, and our own ship's course line. So we'll do our own ship's course line first. And this is very simple. We are doing on 6-minute increments. So we're going to be dividing 20 by 10 because 6 is 60 divided by 10. So 20 divided by 10 is 2. We're going to be measuring out 0 to 2. And then going to our own ships. That's our own ship right here. And going from 0 to 2 on 220 degrees. You'll see me finicky a lot with the radar transfer sheet. I'm simply doing this just to get to measure the best angle. Now that we have that right here, we can now measure out 0 to 220. And draw a line. Double check that measures to 220 just by making sure it lines up. And it does. Just like that. Now that we have that, we need to find our R00 and M06. That is found by using these two given information up here. So our R00 is 269 degrees at 9.4 nautical miles. So we'll measure our 9.4 nautical miles. And go to 0. 0 to, from our ship, will be one end, and our other end will be 269 at 9.4. So 269 at 9.4, and you can see that there was kind of some holes already there. That was from when I worked out the problem again right before this video. 269, and we're just going to label this R00. Now we need to find M06, which is the 1906 number, and that is 268 at 7.0. So same process, 7. And then 268, so it should be really close. 269, 268. Actually, I'm gonna just double check that real quick just to make sure. It should be right here. Right there. And that's 268. 269, 268 at 7.0 nautical miles. Right there. M06. Now to find the DRM, all you have to do is connect these and transfer that to the middle. Now we're going to want to connect these through the center so we can see our CPA and other stuff later on. So there we go. Just drew a simple line like that. Now that we have this, we're going to want to transfer right over to the center and find the angle that it lies at. Since it's going from west to east, it will be around 90-ish, but we don't know exactly where. So I need to get, I'm using as my second triangle, old headphone case. Put it right, line up with the line, and go right through the center. And move right through the center, and we can see right here that it is telling me that it is 91.5, which I'll just round up to 92 degrees. So our DRM is going to be 92 degrees. And when we look at the answer key, it lines up with my answer. Perfect. Our CPA is our closest point of approach. And on this relative bearing line, our CPA would be the distance between our ship and the closest point on the line. So we'll go right here and just bring that back, let it zoom in, let it focus. And if you're thinking that I spent a little bit too much time on this right here, you can do it faster. I'm doing this kind of slow just so everyone can keep up and make sure that this is very precise. Now I'm measuring 0.4, and I'll just double check that real quick. Oh, was off a little bit. Extend that just right there. I know it's hard to zoom in, but that's what I'm getting, and it should, yes it does, to 0.5. So our CPA, from what we're finding, is 0.5 nautical miles. Now we have our DRM and CPA. We need to find our SRM. So our SRM is actually pretty easy to find now that we have R and M. It is the distance between R and M times 10, because this is only 6 minutes. We need to multiply it out for the entire time. So we go from 0 to 2.4, 2.3, 2.4, if you can see that. And that would make it 23 knots. 24 knots. So SRM is 24 knots. And that does wind up with the answer right here. So again, SRM found between this distance right here, 0 to that, and multiply it by 10. Now we are finding our TCPA. This is our time to the closest point of approach, which can be found by getting 0 to 0.6 and simply walking the dividers. So 0 to 0.6, and we're going to walk it once. And that would be 12. From 12, we still have that distance from M to M06. Walk it one more time. And that would be 18. From 18, one more time. And once you know, right where we had our CPA, after we walk it one more time, we're gonna highlight this a little bit so we can see it better, and put 24 because we're going in 6-minute increments, and we can see that our CPA, our TCPA, is found at the exact same spot as our CPA. The TCPA stands for the time to the closest point of approach. So wherever you got your CPA on this relative bearing line, your TCPA will be the same point, but you will just be finding time instead of distance. And that will take 24 minutes to get to that TCPA. So the TCPA will be at 19 plus 24, 1924. And if we check the answer key, we can see that I'm off by a minute, but I am in the leeway. Now we need to do DTM. We can find DTM as it is the direction of true motion. We're going to be extending E to M through the center and finding the angle. But you're probably asking, how do we find E? Well, do you remember how we found our own ship's course at the beginning? If we parallel that to R00 in this direction, we will find where E lies, and it'll be exactly 2 nautical miles off. So let's take our triangle, line it up right here. And find a good way to move it. That'll probably work. There we go. Now that we have that course, that angle at R, we're going to slowly back over here, pull down our triangle, measure out 2. And voila, there's our E. Label that real quick and draw that out. Now that we have that, we're going to connect E to M as well. We could just get the same dot you got from E and drag it down to M. And your triangle should look something like that. This is known as the REM triangle. And E to R is our motion, and E to M is their motion. You remember this is E to M is them, which is their motion, and E to R is our motion. Now that we have that, now we can finally find DTM. So DTM, we send E to M through the center. Just like that. And right through the center. We just need to parallel that over. Just like that. That back up. And voila. There we go. And I'm getting a force of, I think, 145. Yes, 145 for my DTM. That is our true motion, 145. And the correct answer is 145 on the spot. Now we need to find our STM. Our STM is speed of true motion, which is the distance between E to M times 10. Because remember, we're going in 6-minute intervals. Now we got that. Put that right to 0, 2, 9. I think it's 19 knots is what I'm getting. And the correct answer is 20. So we're off by just a tad. Now the last part is our new course that we need to go because of the situation we're in. Now, we need to first identify which rules of the road scenario this is. Is this an overtaking? Is this a head-on? Or is this a crossing? By rules of the road, this would be a crossing. We can envision this as we're going to draw a little vessel just like that. Port and starboard. Now, if we can see their port light, which is red. You, as in us, are the giveaway vessel. We can see their starboard light, we are the stand-on vessel. But since we can see the port, we are the giveaway vessel. Now, what we want to do is use the MX that we had earlier and solve for this. So MX is simply known as the execution point, and it is given in these problems. Our MX in this problem is 5.0 nautical miles. So we're going to go to 0 to 5. And MX is found by taking the distance from your ship to where it is on the relative motion line. So it should be right there. And just keeping track of that. That is my MX. Now that we have the distance from MX to from our ship to the relative motion line, now we need to find where it's tangent to the CPA. But we also need to figure out what direction we need to be going as well. So since we are the giveaway vessel, we need to maneuver ahead to have them pass behind us. within our 2 nautical mile CPA. So we're gonna measure out our MX tangent with our CPA. And our CPA is 2 nautical miles. Just like that, we're going to measure that out. And it should look like a line just like that. Now that you have that line, we need to move this line to the other M. So this is MX, so M to M. Now we're going to parallel this line and this angle right over here. So let's get this angle measured out. Get our trusty compass thingy. Backup triangle, I guess. And then once that is lined up, then we can draw the same line out here. Now don't worry about how far you draw it, but what you do need to know is that this line right here and this line right here need to be parallel. If they are parallel with each other, then you are doing it right. So now the vessel will be passing behind us, and this, if we maneuver correctly and then the correct amount of time, this will be our this is where they will be passing on this new track. Now, to find our NC, we're going to find an R prime first. To find an R prime, all you have to do is put your dividers on E, measuring it out to R00, and swing, pivoting on E where it intersects the new M06 line. It should intersect it, if you're doing this problem, right on this outer line. And if you get that in, right here, this is going to be R prime. Now that we have R prime, we can find our new course. So from E to R prime, and there you go. That is our new course, but we can't really do much with that right there. So let's draw a line between those two and parallel that right to the center. There we go. Just like that. Now we have that line. Let's parallel that. We've been doing the other ones right to the middle. Again, probably not the fastest method, but definitely making sure my work is lining up. And for the sake of this tutorial video, the way I will be doing it, now we have that lined up. Let's parallel this just like this, straight to the middle, and pull that down, turn it, and it does line up right with the middle. Now let's put a little dash right here so we can see what angle this is on. And this is on 254 is the angle I am getting when paralleling this to the middle. And when we look at the new course, is 256, but 256 is in the plus or minus 5 degree leeway that we have. So our NC that I found is 254 degrees. hopefully this video has been of some help and I've been able to properly explain the mechanics of a radar transfer plot. Please let me know if you have any questions, and I'll be making more videos on this weekend. Thank you so much.